We've said before in our course, and we'll say it lots more times, especially during this topic, that really when we're looking to manipulate our algebraic expressions, try to factorise first before we start to expand. Now, that's really important. So, we've just shown you some ones on factorisation, but when you're doing mathematical induction, really try and look for a factorisation before you look for an expansion. Use expanding brackets as the very last option. Always look for factorisation because it's going to save you so many hassles. Because if you don't want to find yourself trying to factorise a cubic. You don't want to get past the quadratic. So if you expand something and get a cubic, you know you've gone too far. So be really careful. In this case, what we want to do again is get our left-hand side down to get it to our right-hand side. So we're looking, again, we're going to have to do some factorisation because we can see some brackets around here. So when we're looking at that, we see, well, what is common? There's not much that's common, so we're going to get out, anything that's a common factor in the whole thing is 2. So we've factorised that, and that's not bad because we've got a 2 out there, so that's okay. What we're left is the k outside the k plus 2, 2 lots of k plus 1 minus 3. And so now, I can't do any more factorisation. I'd like to, but I can't. I can't get a k plus 1 out because it's not a common factor. And that, I see that I do need to get one out, but it's not coming out. So expand it out. It's not too bad because I'm only coming down to a quadratic, which when I collect all terms and clean it up, we get k squared minus 1. That's not a bad quadratic at all. We can factorise that, the outside of k plus 1 and k minus 1, which is pretty good. We got our first two terms there, like 2k plus 1. But what I really want is, I want k plus 1 minus 2. Now here's that decomposition that we were talking about before. So k minus 1 can be written as k plus 1 minus 2. So you can see there's our k plus 1 that we want to get. And the minus 2, we can put another bracket around to make it look like what we wanted. But there's our decomposition to get k minus 1 to k plus 1 minus 2. And we're going to have to do a bit of that just to show that expressions are going to be what we want. So again, in B here, always keep in mind what we want to end up with. So we want a half k out the front. So that's not too bad. We can get a k out the front. We can take a half out as well. That's just going to leave us a 3k plus 1 from this term. And again, we're going to factorise, we've got a 1 there, so we factorise a half out of 1, gives us the 2, outside of 3k plus 1 minus 1. So hopefully what we've got in this bracket will come down to 9k plus 5, because we've got our half k out the front. So expand our brackets, taking care with it. So 3k plus 1, we get 2 outside of the 3k, and 3 minus 1, which gives us a positive 2. Again, span the brackets to get that, and we come down to a required expression. So that's okay. So that wasn't too bad. We didn't have to do, we could be able to factorise first, which is nice. We're going to have to do a bit of work with fractions as well. So again, look at what we need to get. And we got the k plus 1 plus 1 on the bottom. So if we look at what we've got there, when we add two fractions, we need to get a common denominator. So the k over k plus 1, what we really need here is to multiply top and bottom on the left-hand fraction by the k plus 1 plus 1, which is the same as k plus 2. If we really want to put it there, it's k plus 2. And it's just been decomposed. So that's why we've multiplied the k by k plus 2. And we've got the 1 over the common denominator there. Again, we can't factorise it, so let's clean it up and get our quadratic there. Notice I haven't expanded the quadratic yet, because if you notice at this point, I've got the k plus 1 already there. So I'm not going to expand it out. I really all I want to do is get something up the top. I can cancel a k plus 1, because that will leave me my other term there that I want as my final denominator. So the k squared plus 2k plus 1. Again, if I'm looking to if I'm looking to cancel this k plus 1, I should really look, does this factorise into something with a k plus 1 there? And it just happens to be a perfect square. And again, keep in mind that you've got a k plus 1 up the top, and I want to cancel a k plus 1, so really it should come to a k plus 1 all squared, which is going to cancel and leave me what I need for my right hand side. So look at what manipulations you want to get to. So keep in mind your end goal. So So if you keep that in mind, then you know what you're working towards, and you can start to do an easier factorization because you know what you're going to need to cancel from what you've got earlier on in the proof to get down to that last part of the proof. So be really careful. Keep thinking, factorizing before expanding where we can.